All right. Hello, world. Can you hear me okay? Well, so nice to see so many faces from around the world. This is the second of CS50's New Year seminars, an opportunity to learn a little bit about databases and specifically a language called SQL via which you can add and remove and update data that's actually in a database already. Happy to say we've had over 10,000 registrants from around the world for these and our upcoming seminars, and an amazing team of now 600 plus volunteers who have kindly offered to mentor folks, answering questions both in the chat today, but also within Ed, the course's Q&A platform. Indeed, if you have a question today, please feel free to post it right in the chat or after today within Ed. Indeed, if you find that any of today goes a little too quickly for you, if you have technical difficulties or trouble keeping up, not to worry, everything will remain available on the course's website hereafter as well. Before I introduce our teacher for today, we have this tradition, as you may know, of taking group photos before we begin. If anyone would like to turn on their camera to opt into this, and go ahead and put on your best smile and wave. We need a few seconds to page through the 200 plus participants who are now in the Zoom meeting. And we'll go ahead and take a whole bunch of screenshots and then post a mosaic of everyone thereafter online. So we need a few seconds of this so we can clip through all of the screens. Hopefully we'll catch you looking good since we're only taking one screenshot per screen. And then again, we'll use some fancy software that one of our colleagues wrote to extract all of our faces and include them in just one big photo. Andrew, how are we doing? Can we stop waving?
Should be all set, David. Thank you.
All right. Well, without further ado, allow me to introduce CS50's own Brian Yu, who not only teaches CS50's introduction to web programming using Python and JavaScript, but also CS50's introduction to artificial intelligence. Indeed, if after today you would like to dive in all the more to SQL, do consider, if you haven't already, taking CS50X itself, followed by one or both of Brian's classes as well. Brian, over to you.
Thank you so much, David. And welcome everyone to another of CS50's seminars. Today we're going to be introducing SQL, a language which, as David mentioned, is used for dealing with data, manipulating data, trying to query data, and get answers to questions about our data as well. So as we're introducing SQL today, if at any point you have any questions, definitely ask them in the Zoom chat. If you haven't found it already, at the bottom of the Zoom window, you should see a chat button that will let you chat with other classmates. I'll keep an eye on the chat today to try to answer as many questions as I can. But for any questions that I miss, we also have a great team of mentors who are here in the chat as well, who can help to answer questions too. A few logistical things to get out of the way before we get started. First, if you don't already have a GitHub account, go ahead and head to this URL, github.com/join. That will set you up with a GitHub account if you don't already have one, and you'll use that to sign into some of CS50's tools a little bit later today. We also have a course discussion forum that you can use today in addition to the Zoom chat. You can find that at this URL that I just pasted into the chat, cs50.ly/seminars/ed. And there will be certain points during today where I'll actually stop talking and give you a few minutes to try working through some problems on your own. And during those times, if ever you run into any trouble, you're not sure how to approach a problem, turn to Ed as a resource there. You can ask a question there, and other students and the mentors can help you to try to answer those questions. And finally, a little bit later today, we're going to be working in an environment called CS50 IDE, which is at ide.cs50.io. If you've never used it before, it's a cloud-based programming environment that lets you write and run code in the cloud, and we'll be using that a little bit later today. If you have any technical trouble with any of these tools during today, definitely just ask in the chat, and the mentors can try to help you resolve. Meanwhile, all of the materials for today, all of the information about the databases we're using, the slides that I'm going to be showing you, the SQL queries that I'm going to introduce you to, you can find on the website for the seminars, which is here, cs50.harvard.edu/x/2021/seminars. And in particular, at that URL, you'll also be able to find all of the slides for today. And I'll paste the slide link into the chat too, so that if you'd like to follow along with today's slides, you'll find it there. As I start to introduce SQL and the syntax of SQL, if ever I'm moving too fast or you want to go back to a query that I ran before but that's no longer on my screen, you can find most of those queries in those slides as well. And so feel free to turn to those resources too. So with that in mind, let's go ahead and get started. So today is going to be all about data. It's going to be about how we store data, how we organize data, how we answer questions about that data. And so I thought we'd start not with programming and SQL itself, but with a representation of data that you've probably seen before in one way or another, and that's a spreadsheet. So here I'm showing you on my screen a spreadsheet that's taken from data from IMDb, the movie website. And this spreadsheet is all about television shows. It's about a whole bunch of popular television shows. And you can see that there are a whole bunch of rows and columns. And my question for you first is this, and you can feel free to answer the question in the Zoom chat if you'd like to type a response. The question is, how is this data organized? What do the columns represent? What do the rows represent? How is it that I've organized the data in this spreadsheet that you see here right now? Avish is saying that the data is organized in a table. Yeah, absolutely. Everything's in a table with these rows and columns, and storing data in tables or sheets, as a spreadsheet program like Google Sheets might call it. That's one way of organizing this data. All right, I'm seeing a bunch of people saying that every row is a different television show. So we have a whole bunch of television shows, and each row represents some distinct television show. A few people are commenting that this is organized alphabetically, so it makes it a little bit easier to try and find television shows if I'm looking for them. What about the columns? What do columns represent in this spreadsheet? Yeah, I'm seeing different words people are using, characteristics of the shows or fields or properties that represent the shows. And or attributes, each of the columns is representing some information about the show. We have one column for the title of the television show, one column for the year in which the television show first aired, one column for how many episodes that television show has, one column for the rating of the show, that IMDb happens to allow users to rate a television show on a 0 to 10 scale. We have one column for how many users have voted on that television show. We have one column for the genres associated with the show, like this show is action and comedy and fantasy. And we have one column for all of the people that starred in that television show. That goes in another column as well. So that's how this data is organized. But if you imagine trying to look through this data, trying to get answers to questions you might have about this data, and getting a computer to be able to process this data, do you see any potential problems, any drawbacks, any ways in which this data might not be organized the best that it could be? Anything we might be able to improve about the design of this spreadsheet that I have here? Yeah, Suba is saying the genres column. Kelly and Shilpa are talking about the stars column. Yeah, these columns feel a little bit messy, so to speak. Whereas these first 5 columns seem fairly straightforward and clean. We just have a title, a year, episode number, rating number, number of votes. The genres column is a little bit tricky, as Kaio is saying, because of these commas. That these commas are here. So if I'm looking for all of the comedy shows, for example, I have to be careful not just to look for shows that are only comedy, only looking for cells with the word comedy, but looking for comedy, comma, something, for example. And if I sorted by genres, I couldn't just look to the C's to try and find comedy, because comedy, for all I know, might be at the end of the genres list, for example. So you run into some trouble there. Meanwhile, we have a similar problem here with all of the stars, where we have all these names that are just separated by commas. It's a long list of names. Oftentimes, they're going to extend past the boundaries of the cell. And so I'm not even able to see all of the names right now, and they're comma separated, so it's a bit difficult to try and find a particular name if I'm looking for a particular name. And so the question now is, what could we do to improve this? How could we improve the organization of this data? What change could we make to how we've structured the data in the database? Yeah, Mark is suggesting we add more tables. We create a new table to try and store additional information. And that's exactly what we're going to do. And the reason we're going to create new tables through a process called normalization, which I see a few people mentioning in the chat, is to try and clean up these columns. That instead of having these comma-separated lists of values, I'd like for every cell to really just contain one value so that it's easily sortable, it's easily searchable, and ultimately just a little bit better organized. And so let me now show you version 2 of this same data. Here we have our shows table. And again, I'm going to start referring to these sheets as tables. But what's different about this TV show's table when you're comparing this version to the version I just showed you a moment ago? Yeah, a bunch of people are first commenting on this column here, the ID column, which didn't exist before. What's the point of the ID column? Well, the ID column is just giving every television show a unique number, some number that'll uniquely identify that show. And the reason that's useful is so that we have some way of uniquely referencing any particular TV show. We might like to use the title for that, but the problem is that two different shows might have the same title, or many more shows might have the same title for a television show. But I can guarantee, if I've designed my database well, that every television show will have a unique ID. So if I know the ID number, I'll never get confused about which television show I mean. And all right, what else is different other than the ID? Yeah, someone else commented that there's no genres column, there's no stars column. All of that data seems to be gone. But as Mark has suggested in the chat, I have 3 sheets now, or 3 tables here at the bottom represented by tabs. One called shows, one called genres, one called people. Let's look at the genres table first. And this might look a little bit strange. It's a table with only 2 columns, one column called show ID and one column called genre. And even if you've never seen a table like this before, how do you imagine we would interpret this data? What does each row of this data represent? Yeah, it's saying that this television show belongs to this genre. It's associating a show with a genre. And so, for example, this row here is saying that whatever show is show number 4574334, that show is a drama show. And if a show has multiple genres, we represent that with multiple rows here. So we can easily find, okay, this show is drama and fantasy and horror, for example. And so we're representing exactly the same data, but it's a little bit cleaner. Each of these cells only contains one genre. So if I'm looking for all the crime shows, I can just look for all the cells that are exactly the word crime, or I could even sort them and find all of the crime shows more easily. It's a little bit better organized. And I've done the same thing with people too. So here, for example, I'm storing people, associating every show with the name of a person, for example, of a person that starred in that show. And because I have a separate people table, I can now start to store additional information about those people. I can store, for example, what year every person was born, just as another column in this table. And so if a show has multiple stars, as many shows do, we can have a show ID appear multiple times, saying that this show has multiple stars. And if there's a person that happened to star in multiple shows, then that person will just appear in multiple rows of this table, each time associated with a different show ID to indicate each of the different shows that that person starred in. All right, so are there any problems with this design now? I'd argue this is an improvement in terms of the overall organization of the data over version 1. We've normalized the data a little bit, but what's the problem? Yeah, this table is also messy, and as people are discussing in the chat, there's a lot of redundancy, a lot of repetition. The same name is repeated multiple times. Their birth year is repeated multiple times in multiple different places. And so that's going to be storing more information than I need to store. I don't want to store all of this repetitive information. So what could I do instead? What could I do instead? Kevin is suggesting I could separate the first and the last name columns. I could certainly do that. That might be a good idea if I want to keep track of first and last name separately. A number of other people, I see Sophie suggesting we create a separate additional table just for storing people. And so this will actually be the final version of the spreadsheet we'll take a look at. Here's version 3. We've still got our shows table as usual. We've still got our genres table, which looked exactly like it did before. But here's what's new. We have a people table that now only contains every person once. There's no repetition. Every person only appears in this table once. But every person, as Sandul is suggesting in the chat, has a unique ID. Every person has a number associated with that person that's unique to them. And that's going to be true in the same way that it's true for shows. Every television show has a unique ID. Meanwhile, every person has a unique ID too. And so let's now take a look at this final new sheet in this spreadsheet called stars. And now what's going on in the stars table? It looks a bit cryptic. We've got two columns, one column called show ID, one column called person ID. The spreadsheet is just numbers. What does it mean? Yeah, as Kelly is saying, the columns link together the two other tables. I like that framing a lot. We're linking together one show with one person, saying that this person starred in that show. So whatever show is show number 68098, that show has person number 619990 as one of its stars. And if a show has multiple people that starred in it, you'll see multiple rows that have the same show ID, but different person IDs for different people. This table is what we call a join table. It joins together two other tables. We certainly could do this for genres as well. We've chosen not to here, in particular because there are far more people than there are different genres, so we get more of a benefit here. But you certainly could try to make additional adjustments as well. Ken is mentioning that one advantage of this approach is that it's much easier to get all of the shows for one person. If there's a person for whom we want to find out what are all the shows they were in, we could very easily answer that question just by looking up their person ID inside of this sheet. And so with that in mind, let's actually try this. I'm going to send you all a URL in the chat. You can also find this link to from the slides. But if you click on this URL in the chat right now, you should be able to open up your own version of this spreadsheet in a published on the web way. And what I'm going to do now is ask you a few questions about this data. And I'll give you a few minutes on your own where I'll stop talking. And I would like you just to get practice with this structure of the data, which is maybe a different structure than the structure of data you may be familiar with before. Just get some practice trying to answer questions with data represented in this form. And so here's what we're going to do. You're going to open up the spreadsheet. I set the link in the spreadsheet in the chat, but you can also access it through the slides by going to the website for today's seminar. You're going to open up the spreadsheet and use it to answer these 4 questions. Try and answer these 4 questions. Question 1, in what year did Black Mirror first air? Question 2, what are the genres associated with the show Stranger Things? Question 3, who are the stars of The Office? And question 4, what shows has Jennifer Aniston starred in? So I'm going to give you about 10 minutes or so on your own to try to answer these questions by looking at that spreadsheet that I linked to in the chat. If you have questions about anything, feel free to ask them in the chat or ask them on Ed. But we will talk in about 10 minutes about how it is that you could have gone about answering these questions. So I will go ahead and start up a 10-minute timer, which you should be able to see on my video tile. And we'll see you in 10 minutes. All right, welcome back, everyone. Even if you weren't able to make it through all of those questions, hopefully you made a little bit of progress. And let's now talk about them. Talk about how we could have answered them based on the structure of the data that we were given. And let's go ahead and start with question 1. So question 1 was Black Mirror. What year did it first air? What answer did you get, and how did you get that answer? So taking a look at what people are saying, everyone's saying 2011, which sounds correct. So I'm just going to do a Command or Control F on your computer. You can do a search for Black Mirror. And all right, we find Black Mirror first aired in 2011. Everything is just here inside of the shows table. So we went on to question 2 now, a little bit trickier. Stranger Things. What genres are associated with Stranger Things? All right, drama and fantasy and horror people are saying, how did you figure that out? One is saying you searched for the name Stranger Things in the shows table, and then you got Stranger Things' ID. And that'll be a step we'll see a lot today, is if you want to find out information about something, first get its ID so you can do something with that ID. So we get its ID, 4574334, and now I can head over to the genres table, as people are saying. I'm going to search for that ID, and I do see now drama and fantasy and horror are the 3 genres for that show. Great. Let's go on now to question 3, which was The Office. Who are the stars of The Office? And how did you get that answer? I'm seeing a lot of names. Yeah, people are saying first, find the ID of the show. So I'm going to go back to the shows tab. I'm going to search for The Office. Here's the ID, 386676. And now which table do I go to? The stars table, Danielle is suggesting. Very good. The stars table, remember, is the table that associates a show with the people who starred in it. So if I want to know who starred in The Office, I have to look for The Office's ID. And here I'll find all of the person IDs of people who starred in The Office. And now at that point, you could take each of those person IDs, look them up one by one in the people table, and you'd be able to figure out their names. I could take the first one, for example, go to the people table, I could look up the ID, and I could find the name. And I could repeat that process for every person ID that happens to appear here. A bit of a tedious process, and remember that, because in a moment, we'll see if we can come up with ways we could have made this a little bit more efficient with the help of SQL, but we're getting ahead of ourselves there. Let's now go to question 4. Jennifer Aniston, what television shows has she starred in, according to this spreadsheet at least? Friends is one of them. There's another. All right, The Morning Show. A couple of you identified the second one, at least according to this spreadsheet. And how would you have figured that out? All right, so we need Jennifer Aniston's ID first. So I'd go to the people table. I'll look up Jennifer Aniston. Here she is. Her ID is number 98. And so I can go now to the stars table, and I want to look up person ID 98 and effectively do the opposite of what we just did a moment ago. I want to find all of the shows associated with person number 98. So I could do a search for 98, and I'm getting 381 results according to my just search function here. Are there 381 shows that Jennifer Aniston has starred in? No, because it's not an exact match. Exactly right. And when I'm searching for 98, I'm finding person ID 933988, which has 98 somewhere inside of it. And there are other shows that are just going to have the number 98 somewhere in their ID and people with that. And so this is going to be a bit tricky. I'm just going to have to search and try and find all the ones that are exactly 98. Now, I saw a couple people try and download this into a spreadsheet of their own where you could sort and try and do filters on it. But the point was, this was probably a pretty manual, pretty tedious process to try and find all of the 98s, make sure you didn't miss any, find the shows, and then look it up. I'm seeing some people in the chat agreeing this was kind of tedious. So there's got to be a better way to do this. And the better way to do this is going to be to introduce a new language. And that language is called SQL. It's what we're going to be talking about today. And SQL is a language for dealing with relational databases. And a relational database is really just databases that are structured the way we've structured this data here, organizing data into tables that have relationships between one another. The shows table has a relationship to the stars table, which has a relationship to the people table. And what SQL is going to allow us to do once we can speak this language is to use SQL to write a query, to ask a question about the data in our database, and then our database will just give us the answer. And so to do that, we're going to actually leave the world of spreadsheets for now and turn our attention to the world of programming by going to ide.cs50.io. So go ahead, if you aren't already there, head over to ide.cs50.io. This is CS50 IDE, and you'll be prompted to sign in with your GitHub account. And if you've never used CS50 IDE before, the way it's structured is that on the left-hand side is our file browser. This is where all of the files are inside of our virtual computer in the cloud. If you're using it for the first time, then like my IDE, you won't have any files there, but we'll change that shortly. And then down below, and I'm going to make it a little bit bigger for today, is what's called the terminal window. The terminal window, and you'll see this $, which is a prompt for you to start typing. This terminal window is where you can start to type commands that you would like the IDE to follow. And we'll be using those commands here too. You can use the sandbox, Ahmed, if you'd like to instead, that's fine. But the IDE will just be set up as well to do everything we're going to do here today. So this terminal window is where you can start writing commands that ultimately you're going to run inside of the IDE. And the first command we're going to run is a command that's going to download the database that we're going to be using. I've prepared in advance what's called a SQLite database. SQLite is just one type of database that uses the SQL language, though there are others. And the way we're going to access this database is by running this command inside of CS50 IDE. So I'm going to go ahead and paste this into the chat. wget followed by this URL. And if you were to take that command, which I'm also showing on this slide, and at the $, when you see this $, go ahead and just paste in that command, wget followed by this URL. What you're going to see is you're going to see the shows.db database download into your own file system. And so inside of your file browser, you should see shows.db appear on this side. So here's that command once again. You're going to paste that when you see the $, and just press return. And after you do that, the shows.db file will download and you'll see it in the file browser inside of your IDE. So I'll give you a moment to get caught up on that. And once you've downloaded the database by saying wget followed by the URL, now what we'd like to do is open up this database so we can start asking questions about the data and start trying to figure out the answers. And the way that we're going to do that is at the terminal prompt, when you see this $, go ahead and type SQLite3, SQLITE3 without spaces, then add a space after that, and type the name of the database file you'd like to open. So today we're going to open shows.db. The .db is just an extension telling us this is indeed a database. And I'll press return. And when you press return after typing SQLite3 shows.db, assuming that you've downloaded the shows.db database in advance, what you'll see is a new prompt that looks like this. SQLite followed by an arrow. This means SQLite is now running, and you can now write SQL queries, commands to this database to try and access information about the database. So the two steps I followed so far inside of CS50 IDE was step number 1, run this command, wget, followed by the URL of the database to download the database into your CS50 IDE. And then second, once you've downloaded it, you can run SQLite3 shows.db at the terminal prompt, again, where you see that $, and that's going to open up the database for us so that we can start running some commands. Give you a moment to catch up. All right, so what can we do now that we're inside of the database? We're at the database prompt here. Well, the first thing that I often like to do is get an understanding for how the database is structured. Remember that a relational database is organized very similar to the spreadsheets we were looking at before. It's organized into tables, where those tables have columns, and each row of the table represents one piece of data. And so before I can start asking questions about the data, I first need to understand how the data is organized. And the way I can do that is by looking at what's called the structure or the schema of this database. And the way I can do that is at the prompt type dot schema, dot schema, no spaces. And then after that, press return. And what you're going to see a bit cryptically once you do this is a detailed description of how each of the tables of this database is structured. And so you don't have to understand every word of what you see here, but I'm going to try and talk you through what the key relevant points are. So here at the top, you see we have a new table called shows. So one of the tables in this database is called shows. And again, I got here by typing dot schema, dot schema, and then pressing return. I have one table called shows, inside of which are a number of columns. There's a column called ID, a column called title for the title of the show, a column called year for what year the show first aired, and a column called episodes for how many episodes the show has. Meanwhile, we also have a table called genres. Much like the genres table we saw before in the spreadsheet, we have a show ID column, which is a number, and genre, which is going to be the genre that we're representing here. And notice that if you've programmed before in another programming language like C or Python, for example, you might be familiar with the idea that data has types. Every data has some type associated with it. That's true in SQL too. Show ID is an integer. It's going to be just some number representing the ID of the show. And meanwhile, genre, that's just some text representing the genre for that television show. Meanwhile, we also have a table for the stars of the television show. This is structured much like the stars table we saw before. It associates the ID of a show, which is a number, with the ID of a person, also a number, saying that this show has that person as one of the stars of the show. And then we have a couple of new tables that weren't there before. We have one table called writers that we didn't talk about before, but this you should be able to infer is very similar to the table for stars. Much in the same way that I might want to know who starred in any given television show, I might also care about knowing who wrote any given television show. And that's what the writers table is for. The writers table associates the ID of a show with the ID of a person who wrote that show. Again, with columns called show ID and person ID in exactly the same way. Meanwhile, we have a table of ratings. It turns out IMDb separates its ratings into an entirely separate table. This table has one column called show ID for the ID of what show we're representing ratings for. One column called rating, that is just a number between 0 and 10. What is the rating of the show? And one column called votes. How many people have voted for that show? And finally, we have a table called people that has every person has an ID, every person has a name, and a year in which they were born. So you don't have to memorize all of that. If ever you forget, you can always type dot schema, then return, and then you'll be able to see all of this again. A couple of terms I glossed over. Primary key here just means that ID is going to be the main way that we uniquely identify rows in this table. Every person is going to be uniquely identified by their ID, because a name might not be enough to uniquely identify a person. Maybe two different people have the same name. Maybe two different people have the same year of birth. But we can guarantee that every person will have a distinct ID. So ID is our primary key. It's how we uniquely identify rows in this table. Meanwhile, here in the writers table, for example, a foreign key is saying that one of the columns of this table is referencing some other key in another table. Here, the person ID column in the writers table is making reference to the people table and specifically the ID column in that table. And so this is just my way of describing in this database how it is that these pieces of data are linked together, how it is that my tables relate to each other in this relational database. Kate is asking, could a person be both a writer and a star of a show? Absolutely. They'd appear one time in the people table, but you might see that person ID appear in the writers table if they wrote a show. And if they also starred in a show, they might separately appear in the stars table as well. Mark is asking, what does real mean? Real just means a real number. In other words, a number that might have something after the decimal. So a rating might not be only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A show could have a rating of 2.8, for example, something after the decimal, and we'd want to take that in consideration. Lakshanta's asking about not null and what that means. And not null just means the field can't be blank. And so here we're saying name is text and it's not null, meaning that no person is allowed to have an empty name field. For every person, there must be a name field. But notice that the birth year, for example, doesn't have that constraint, because maybe we just don't know the year of birth for a person. So we're okay with letting that column be blank sometimes. So not null just enforces which columns we never want to allow to be blank. All of this was set up for us when the database was first created. And if you wanted to create your own database, you would write commands like this to create your own tables in that database. But today, we're not going to be creating our own databases. We're just going to be using this database that already exists. And so how do we use it? How do we do something now with this database that already exists? Well, I'm going to write a SQL query, a question about the database that I would like answered. And my very first query, and for all of the queries I'm about to show you, you can find them in the slides, and I'll link you to the slides again. So if ever I go past a query and it's no longer on my screen and you want to go back to it, you can always find the queries that I'm about to run in the slides as well. But the first query I'm going to run looks like this. At the SQLite prompt, where it says SQLite and then an arrow, I'm going to say select star from shows and then a semicolon. So what's going on here? What does the query mean? Well, the word select means I would like to get data from my SQLite database. Then I need to tell SQLite, what columns do I want data for? I'm selecting data from a table. Which columns do I care about? Maybe I care about only one column. Maybe care about two columns. Maybe I care about all of the columns. The star here just means all of the columns. It means I would like to select data for all of the columns in the table that I'm looking at. And then after that, I need to tell SQL, what table do I want the data from? We just saw a whole bunch of tables, stars and genres and people and shows and writers and ratings, for example. And so here I'm saying select star from shows, meaning from the table that is called shows. So I'm going to type select star from shows, semicolon, to mean select all of the columns from the shows table. And then when I press return, what you're going to see printed to my screen are all of the television shows in the database. It's a lot of television shows, as you can see. So it's taking some time to print all of them to my screen. Yeah, it's not stopping for me either. It's going quite a long ways, and it's going to be at least a couple more seconds before we get all of them. But what we've asked the database for is all of the columns for all of the rows from the shows table, which in IMDb's case is a lot of television shows. We're getting all of them right now to get all of this data here. All right, and finally, it seems things have stopped, and we do see the SQLite prompt again. And when we see that prompt, that means the query is done. We can write another query now if we would like to. So we've gotten all of this data from the database, but that's not all that helpful if we're trying to ask a very specific question. Before, for example, I was trying to answer the question, in what year was Black Mirror first released? What year did it first air? And so a reasonable question might be, how do I answer that with this database? I could look through all of these rows trying to find Black Mirror, but that's going to take me a lot of time. That's a lot of manual work on my part. I would like for my database to take care of that for me. How do I do that? Well, what I'm going to write at the SQLite prompt is I'm going to start it the same way. Select star from shows, meaning get me all the columns from the shows table. But I'm going to add a clause to the query. Before the semicolon, I'm going to say select star from shows where title, remember title is the name of one of the columns of the shows table, where title equals Black Mirror. And then a semicolon. And the title Black Mirror, I've put that in quotation marks. So select star from shows, get me all of the columns from the shows table where the title of the show is equal to Black Mirror. And now I'm saying, don't give me all of the rows from the shows table. Only give me the rows of the shows table that match this filtering criteria. I want to filter down to only the rows whose title is Black Mirror. And so now when I run this query, I just get one result instead of hundreds of thousands. And that one result is indeed Black Mirror. And I can see, all right, the year in which it first aired, 2011. So I ask the question and SQLite gives it to me. This time I only got one result back from the database. That won't always be the case though. Imagine, for example, I did select star from shows where title equals The Office. Same structure for the query, still selecting from the shows table, still looking for a title, but this time with a different show, with The Office. And now when I press return, you'll notice I get multiple results. I get 6 results instead of just 1, because it turns out there are multiple shows, 6 shows in fact, according to IMDb's database, that are called The Office. And maybe I don't care about the ID of the show, and maybe I don't care about the number of episodes in the show. Maybe I only care about the title of the show and the year. If that's the case, then instead of saying select star to mean get me all of the columns from this query, I can instead say select title, comma, year to only get the title column and the year column, and the rest of the query is the same, from shows where title equals The Office. So this query, select title, comma, year from shows where title equals The Office. It does exactly the same thing, but now instead of getting all 4 of the columns, I'm only getting 2 of the columns. I'm getting 1 column for the title and 1 column for the year. Yan is asking, why is The Office and Black Mirror in quotation marks? It's because in programming terms, it's what we call a string. It's some text. And anytime I'm representing text, like words, I'll generally put those in quotation marks to search for them. All right, so let's try something else. Imagine I wanted to know what the upcoming shows are, like the current news shows. I want all of the shows that are going to be released this year or sometime in the future. IMDb maybe has some shows from 2022 already, for example, and maybe I want to get access to those too. So what query could I write to get all of the shows that are going to be released this year or in a future year? Any ideas? Yeah, people are suggesting I could use greater than or equal to. Sophie is suggesting I add where a year is greater than 2020 to the end of the query. I like that a lot. I'll do exactly that. There are other ways you could have done it, but I'm just going to say select star from shows where year is greater than 2020. And I'll press return. And when I do that, select star from shows where year is greater than 2020. That's going to give me all of the shows that are released in a year greater than 2020. So some of these shows are 2021. There are a couple that are going to be 2022 in here. I see at least one, and there are probably a couple of others. So I've got shows now that are released now or sometime in the future from this query. Select star from shows where year is greater than 2020. You could have also done greater than or equal to 2021. That would have been fine too, as another way of doing this as well. But now, what if I wanted to know, for example, a question I might want to ask is, how many of these shows are there? How many shows are going to be released this year or at some point in the future? Well, I could count them up. I could just one by one count, all right, how many rows are there? And just count one by one. And that would take me a while, but not crazy long. But it would get harder as there are more and more rows that get added here. And so what I can take advantage of is I can take advantage of the fact that SQL has functions, some built-in operations that I can perform on the data, much as other programming languages, if you've programmed a little before, also have some built-in functions that we can use. And one of those functions is called count. And I can say, for example, select not star, meaning all of the columns, but count star, meaning count how many results I get back. So select count star from shows where year is greater than 2020. Now, instead of saying, get me all of the shows where the year is greater than 2020, I'm saying, get me the count of all of the shows where the year is greater than 2020. Get me how many of them there are. I'll press return, and I see that the answer, indeed, is 615. That's the number of rows we got back. So count just made it a lot faster for me to try to get that answer. So we have these built-in functions that ultimately can be quite useful. One other example of syntax that I'll show you before we move on to something else is, imagine I wanted to find all of the television shows about the Titanic. Very interested in the Titanic. I'd like to find all the television shows that are about the Titanic, that maybe have the word Titanic in the title, for example. So I could ask a question like select star from shows where title equals Titanic, but nothing happened. I got no results. And that's because it turns out there's no television show in IMDb's database that's literally just called Titanic. What I'm looking for is not a title that's exactly the word Titanic, but a title that has the word Titanic somewhere in there, for example. And so here I could instead say select star from shows where title not equals Titanic, but where title is like the following string. I'm going to say percent Titanic percent. And the percent here just stands for a wildcard. It means any characters can go here. So here I'm saying, get me all of the shows where the title follows this pattern. It's some number of characters followed by the word Titanic, followed by any characters, for example. And so I press return, and now I get a whole bunch of results. I get a whole bunch of results of television shows that just so happen to have the word Titanic somewhere in the title. Manisha is asking about case sensitivity. These keywords, select and from and where and like, they're not case sensitive. They could be lowercase if you wanted to. It is often a convention to put them in uppercase. And the reason is I want to distinguish the keywords of SQL, things that are part of the SQL language itself. I want to separate those from the particulars of my database, the names of tables or the names of columns. And so today I am going to be using all capital letters for all of the keywords like select and from and where and like, and I'm going to be using lowercase letters for all of my table names and my column names for shows and for the title. So with this information in mind, with all of this new syntax we've been introduced to, we should be able to answer some of these questions. Like if I gave you a question like, what are the genres for Stranger Things? How could you go about trying to answer that question using this database? What do I need first? Yeah, Danielle is saying I need the ID of this show, Stranger Things. And a few people are saying they're stuck in the SQLite prompt and they're having a hard time getting out. If ever you're just totally stuck at the SQLite prompt, just press Control-C on your keyboard. Control-C will exit out of SQLite for you, and you'll end up back at this $ prompt. And when you're at the $ prompt, then you can type SQLite3 shows.db again, and that will allow you to re-enter the database, and you'll be able to start fresh with a new query. All right, so if I want to figure out what the genres are for Stranger Things, let me first select star from shows where the title equals Stranger Things. And when we do that, we actually get two results. It turns out there are two shows in IMDb's database that have the title Stranger Things. And I don't know which one exactly mine was referring to, but I know it was probably the more recent one. It's probably the one in 2016. So if I only wanted to get that result, the show released in 2016, it turns out you can chain multiple conditions together in SQL just by using the word and. So I could say, for example, select star from shows where title equals Stranger Things and year equals 2016. And when I do that, now I only get one result, and that one result is Stranger Things with the year 2016. And I've also got its ID now, 4574334. What query do I run now to get the genres for Stranger Things? Yeah, it's in a table called genres. And if you don't remember how the table is structured, you could type .schema again to see it. Or to be a little more specific, I can say .schema genres to say, just give me literally only the genres table. How is it structured? All right, the genres table has two columns. One column called show ID and one column called genre. And so here I can say, select genre from genres where show ID equals, oops, let me go back and get the ID of Stranger Things. Now I want to, select genre from genres where the show ID is that number that I just copied. And when I run this query, I get the answer to my question. Stranger Things has three genres: drama and fantasy and horror. And again, I knew I could do that because I ran .schema to see the structure of my database, to know what tables I have and what the columns are in each of those tables. It turns out to introduce a slightly more advanced topic in SQL that you don't need to use today if you don't want to, but it's a good thing to know about. It turns out that rather than do this in two separate queries, you can in SQL combine two queries into a single query by nesting those queries together. And here's how that works. I start with the question I ultimately want the answer to. Ultimately, I want genres. So let me select genre from genres where show ID equals. So far, it's the same as the query I ran before, but here's where it's going to be different. Instead of just pasting the ID in, imagine I don't know the ID. How could I get the ID? Well, this query here that we ran originally, select star from shows where title equals Stranger Things and year equals 2016, that gave me the ID. And so I can include a version of that query as a nested query inside the query I'm writing right now. So inside of parentheses, and I'm going onto a new line just for space reasons, but you don't have to do this. Let me select ID from shows where title equals Stranger Things and year equals 2016. So it's the same as what I just did a moment ago, selecting the genre from the genres table where the show ID is the ID of Stranger Things. The only difference now is that instead of just pasting in the ID of Stranger Things that I already knew, I instead included another query, a query that would find us the ID of Stranger Things and give it back to us. And now when I press return, we get exactly the same answer because I did exactly the same thing. Drama and fantasy and horror are now my results. Priscilla is asking, could we nest queries multiple times? Yes, absolutely. And I'm going to ask you a question in a moment where you'll have an opportunity to do just that if you would like to. Hung Jae is asking, how do you get the structure of the database to do that? You can type .schema, .schema when you're at the SQLite prompt. And when you press return, you'll be able to see all of these tables along with the columns that are in them. Georgios is also a keyword in SQL. I'm going to be using the equal sign for today, though. All right, so what were the other questions that we were trying to answer? One of the questions was, who starred in The Office? How might we answer that? What would you do to try and answer the question of who starred in The Office? Where would you begin? Mark is saying, let's get the ID of The Office. Great, Jasmine's saying the same thing. Let's do that. Select ID from shows where title equals The Office. Ooh, okay. I didn't just get one ID. I got a whole bunch of IDs. I don't really know what to do here, so let me select all of the columns first. Select star from shows where title equals The Office, so I can see in more detail what's going on. there's a whole bunch of different shows called The Office. Which one do I mean? I don't remember what year it aired, but I know it had a lot of episodes. So I'm going to make a guess and say The Office that I care about is the one that had the most episodes out of all of these shows. And now in this case, there's only 6, so it's pretty obvious that I can see, all right, this is the one that had the most episodes. That must be the one that I'm talking about. But it won't always be that obvious. It might be helpful for me to organize this data in some sort of way. And the way that I can do that is like this. Instead of just select star from shows where title equals The Office, I'm just going to copy that. But I'm going to add another clause. I'm going to say order by episodes. I would like to put all of these shows in order by how many episodes they have. And now when I press return, I get the same results, but in a different order. They're now in order by episode. 6 first, then 8, then 14, then 28, then 30, then 188. And so if you wanted to sort data in order by a particular column, this is a relatively clean way of accomplishing that. Just add an order by clause, and then we achieve that effect. A few people are hinting at what I want to do next, which is not necessarily display the episodes in ascending order, but to put them in reverse order, put them in descending order from most number of episodes to fewest number of episodes, in answer to Avisha's question about how you make it descending. The way you make it descending is you start with exactly the same query. I'm just going to copy paste it. Select star from shows where title is equal to The Office, order by episodes, but at the end I add the letters D-E-S-C. D-E-S-C for descending order. Now I press return. And now they are, in fact, in descending order. Most number of episodes first, going down from there. And to add one final flourish to this query, if I don't care about the other 5 results, I only care about the top number 1 show with the most episodes, I can add yet another clause to the query. I can add limit 1 to the end of my query. And limit 1 just says limit my results to the top 1 result. Just give me 1 result from this query. And when I run this now, select star from shows where title equals The Office, order by episodes descending, limit 1, what that is going to do is it's going to take all of the shows called The Office, put them in descending order by their number of episodes, and limit myself to just 1 result. So I get just this 1 show called The Office, and I get its ID. So now I can do something with that ID. What can I do with the ID? What's the next thing I need to do now that I have the ID of The Office? Find the stars, find the person IDs. Very good. All of that data is located in the stars table, and I want to get the person IDs. So let me select person ID from the stars table where the show ID is, let me go back into the database. Here was the query I ran to get just the ID of The Office. Now I'm going to say select person ID from stars where show ID equals 386676. That's the ID of The Office. And when I do that, I get a whole bunch of person IDs. And I could look up their names one by one, going to the people table, looking up those names one at a time to figure out what is the name of this person, what is the name of that person. But again, that's a very tedious process. I'd like to be able to do this a little bit more efficiently. And I can achieve that via nesting queries together again. And here's what this is going to look like. I'm going to select name from the people table where the ID is in, and I'm going to explain this in keyword in just a moment, but then in parentheses, this query that I just ran, this query that got me all of the person IDs from the stars table where the show ID was equal to that show ID. I run that and I get a list of names. So why did that work? What did I do? Well, this innermost query got me the person IDs from the stars table for any person ID who starred in the show ID 386676, which is The Office's show ID. Meanwhile, up here, I'm saying give me the name of all of the people where the ID is in that list of person IDs. I didn't say ID equals because equals only checks against one value. So if I had one ID and I wanted to see is the ID equal to that, I would use an equal sign. But here there's multiple person IDs. I have a whole list of person IDs. And so I can say, get me the names of the people where the ID is in this list. And that is going to get me the names now of all of their people. And we don't have to know their IDs in order to do that. And yes, if you wanted to, you could nest one more time to include yet another query here to avoid needing to put the show ID in there as well. And you'd end up with 3 nested queries. I'll leave that as an exercise to you if you'd like to try to do that. All right, so we have now seen a lot of new syntax. Not to worry if you're feeling like the syntax has been a lot. It turns out that's the end of the syntax that I'm going to be showing here. In terms of new syntax we're going to be learning for SQL. The rest of today is going to be an opportunity to better understand what we're doing here and get some practice and hopefully a fun example at the end to really put SQL in practice and to show how to use this type of syntax. Kaio is saying the syntax is kind of intuitive, and I agree. SQL is designed to read kind of like human language. You can read aloud, oh, just select me the names from the people table where the ID is in this list. And so there's a sense in which SQL very naturally follows from how you would describe the question that you're looking for the answer to. You just have to be maybe a little bit more precise than you might traditionally be used to being when you're just having normal human conversation, for example. But let me now take this opportunity to stop talking and give you an opportunity to put SQL to practice and to try these queries for yourself. I'll first mention that all of the queries that I just ran, you can find in the slides from today, in case you'd like to go back to them, review any of the syntax that I used just now for SQL. But here now are some questions for you to answer. Again, these questions are also in the slides. And here they are. If you haven't already run wget on the database, you can run wget on the database to download it. If you already have, it's the same database. You don't have to download it again, but you're going to use this database to try and answer these 5 questions. Question 1, in what year was Jerry Seinfeld born? Question 2, how many shows inside the database have a perfect 10.0 rating? Question 3, what genres are associated with the show The Crown? Question 4, who wrote Arrested Development? And question 5, what shows has Allison Janney starred in? And as you work through these, keep track of what SQL query or queries you use to answer the questions. I'm going to be interested not just in what your answer is, but also what query you ran in order to figure out the answer to that question as well. So in a moment, I'm going to stop talking, give you about 15 minutes or so to try and answer these questions. If you run into any trouble at all, ask a question in the chat to get help from the mentors who are here today. You can also ask a question on Ed, the course's discussion forum. Here's what it looks like. You can click on New Thread to ask a new question. You'll click on the question button to ask a question, and then just click on SQL, which is the category for today's seminar. You can ask a question there about any of the problems you're working through, and we have a great team of mentors who are here to answer questions as well. But again, 15 minutes to try and answer these questions that you see here. I'm going to go ahead and start a timer for 15 minutes, and I will see you in 15 minutes. All right, welcome back, everyone. Again, no worries at all if you didn't manage to get through all of the questions, but hopefully you made a little bit of progress. We'll talk now about how it is you could have gone about answering these questions by running SQL queries on the database that was provided to you. So let's start with the first one. First question was asking you about Jerry Seinfeld and what year he was born in. How did people go about answering the question? And I'm interested in not just your answer, but how you got your answer. Yeah, so you might have recognized that the people table had a column called birth. If you forgot that, you could have run .schema and then people to see, all right, here's the people table. There's a column called birth. So let me go ahead and just select star or select birth from, or I'll just select birth from people where name equals Jerry Seinfeld. And we see that Jerry Seinfeld was indeed born in 1954. All right, the second question asked about how many shows have a perfect 10.0 rating. How did you approach that? Yeah, the first question to answer, which I see many of you have gotten, is figuring out which table you're going to query from. And if you didn't know, you could run .schema again, .schema, to see all of the tables. And you might have noticed that here there's a table that was created called ratings. And in the ratings table, we have a column called rating. So I could first say, all right, let me just select star from ratings where rating equals 10.0. Like find me all of the shows that have a rating of 10.0. And I would run that query and I'd get a whole bunch of shows that have a rating of 10.0. And this would have been enough. This isn't a wrong answer because you could then count. You could just count and see, all right, how many rows do I have? But the counting's a manual process and we can let SQL do the counting for us, as I see many of you have done, which is just to say, instead of select star from ratings where rating equals 10, instead of the star, I'm going to say select count star. Count star from ratings where rating equals 10.0. And we see that the answer is 27. For those of you who are finding the syntax of SQL a little bit clunky, yeah, totally normal to feel like it's a bit tricky to wrap your head around the way you have to think in order to write queries in this way. It does just come with practice. And for now, my recommendation would be to really start by thinking about where your data is stored in terms of in what table and in what column, and then figuring out which columns you're going to need to access to filter down your results, try and extract the results that you're interested in getting. All right, let's go on to the next question now. The Crown was a show. We wanted to know what are the genres associated with that show. All right, there were multiple ways of doing it, and I'm seeing multiple ways in the chat too. One way was to do this in two separate queries. Query number one would have been, all right, I want to know what genres are associated with The Crown. Let's figure out the ID of The Crown. And that might help answer Manisha's question too, which is like, is The Crown even a unique name for a show? We can find out. Let's select ID from shows where title equals The Crown. And fortunately for us, there's only one. So there's only one show in the database that has an ID of The Crown. So I can take that ID and now say, select genre from the genres table where show ID equals that ID, the ID that I just got from the previous query. And that would give me the answer that you're all getting, which is drama and history. So it was a two-step process. First, figure out what is the ID of The Crown. And then step two, once I know the ID of The Crown, I can look it up in the genres table to try and figure out what are the genres that are associated with that television show. Of course, I saw many of you take the additional step, which wasn't required, but you could have done it, of trying to nest these queries together. And if you were going to nest the queries together into just one query, you would have started the same way as the second query. You would have said, select genre from genres, where show ID equals. But instead of just including the ID of The Crown, you would have included in parentheses, and here I'm just pressing return to get myself onto a new line so that we can start writing queries on a new line instead. I'm going to add parentheses, and then in parentheses include that query from before, our original query, which just gives us the ID of The Crown. And this query gives you the same answer, drama and history, because it's doing the same thing. It first gets the ID of The Crown, and then it uses that ID inside of this outer query that is trying to query from the genres table to try and figure out what the correct genres ought to be. I'll pause here to give people an opportunity to follow along. All right, not seeing any questions yet. So we'll move on to the next question. Arrested development. I want to know who wrote it. How are we going to figure that out? I'm liking the answers I'm seeing in the chat. Give people a moment to answer if they'd like to. Yeah, as many of you have caught on to, this was a 3-step process. There are 3 different tables I need to look at to get this information. First, Arrested Development, the title of that show, that's in the shows table. Who wrote that show? That information's in the writers table. But the names of all the people, that's in the people table. 3 different shows. Again, you could have used .schema to try and figure that out. But now, let's try and figure out how we would take those 3 tables and get the information we need. So first, I need to figure out what is Arrested Development's ID, right? The ID is the key to everything. So select ID from shows where title equals Arrested Development, and we get an ID. I'm going to take that ID, and now which table do I look at? Which table do I look at now? The writers table. Thank you, Rachel. The writers table, again, associates the name of a show or the ID of a show with the ID of a person who wrote that show. So if I want the person's ID, I'm going to select person ID from writers, where the show ID is equal to, and then that show ID. So I do that, and I get a new ID. This time it's not the ID of a show, but an ID of a person. Person 403804. And there could have been multiple people if multiple people had written the show. It just so happens that this show only has one main writer, it would seem. And so now I can say select name from people where ID equals that ID, and I get the writer. So 3 queries, 1 to figure out what is Arrested Development's ID. Once I know Arrested Development's ID, I look at the writers table to figure out what are the IDs of the writers who wrote that show. And once I have the ID of the writer, 1 query to look at the people table to try and figure out what their name is. And of course, as I'm seeing many of you do in the chat, you could again nest this. This time it would be a triple nesting. There are 3 queries that I'm nesting together, and it would look like this. Select name from people, where ID equals if I know there's only going to be 1 writer. But if there might be multiple writers, I'm safer using in, because there might be multiple people who have written this show. And then instead of providing the literal ID of a person, in parentheses, I'll use this query that gave me the ID of a person. Select person ID from writers, where show ID equals. And previously, I just pasted in the ID of Arrested Development. But this time, I'm again on a new line, going to, in parentheses, include this query, which gets me the ID of Arrested Development. I opened up 2 parentheses. So I'm going to have 2 closing parentheses and then a semicolon. And this 1 query that combined the 3 previous queries that we showed separately before, this is now going to nest everything together and give me the same answer, but now just with a single query. And now finally, the last question I asked you to answer was about Allison Janney, figuring out what shows she had starred in. And how did you figure that out? All right, again, this is a multiple step process. And you can think of this as the opposite of the question we just asked. Before we had a show, I had to figure out who wrote that show by going through the shows to the writers table to the people table. This time we're going in the opposite direction. We're starting with a person. I have a name. I want to figure out what shows they starred in, and then I want to get the titles of those shows. So let me first get her ID, select ID from people, where name equals Allison Janney. I get an ID, 5049. I'll take that ID and say, all right, what are the shows that she started? Select all of the show IDs from the shows table, where person ID equals 5049. Oh, sorry, I shouldn't have selected from the shows table. My mistake was I should have instead selected from the stars table. The shows table only has shows. The stars table is the table that links together a show and a person. So I'm going to select from the stars table instead. And now I get the right answers, which are a whole bunch of show IDs. And now I could look up each of those show IDs one by one, but I'll save a bunch of time rather than look these up individually by instead nesting these together. And the way I could nest them together, much as we've been doing already, is like this. Select the title from the shows table where the ID equals or in. Which should I use here? Equals or in? In, very good. And the reason why is because it's not just one show that I'm looking for. I'm looking for any show where the ID is in this entire sequence of shows, where the ID is in, and then in parentheses, I'm going to include this query, which gave me all of those shows. And so now I have the titles of all of those shows. I saw many of you do a third nesting to nest for the person ID too, which you absolutely could have done, but this way works as well. So hopefully you're starting to get the idea now of these relational databases where we have data across different tables, but the data is related to each other. So we can use information we get from one table to look up in another table to try and figure out the answers to the questions we're looking for. And these are not the only ways you could solve these problems. I'm seeing a couple people in the chat mentioning joins. That's another feature of SQL. We're not going to dive into it much today, but it allows you to take two tables and effectively combine or join those tables together. And that could be used too to solve these kinds of problems as well. So there are other aspects of SQL syntax that we aren't going to see today. Today is meant as just a taste of the language to get an idea of what it is and what it can do, but certainly other pieces of SQL syntax too. All right, so the last thing that we're going to do together is I have a bit of a mystery for you to solve, a problem for you to work on. And this mystery comes from the town of 50ville, which is a nearby town. And in the town of 50ville, it turns out that our CS50 duck has been stolen. It was stolen a few months ago. And the town of 50ville has called upon all of you in today's session today to help us try and solve this mystery of the stolen duck. The authorities believe the thief stole the duck, and then shortly afterwards, the thief took a flight to get out of town. And we think they had an accomplice, someone who helped them to steal the duck as well. So your goal is to try to identify, number one, who the thief is, number two, where they escaped to, what city they left to, and number three, who the thief's accomplice is who helped them escape. So we're asking you all to be detectives today to try and help us solve this mystery. We do have a little bit of information for you. Information number one, I can tell you the theft took place on July 28th. July 28th was the date that the theft took place on. I can also tell you the theft took place on Chamberlain Street, which is one of the streets in the town. Chamberlain Street is one of the streets in the town. And using that information, we're going to let you try and solve this mystery. We do have a little more information for you, actually. The town of 50ville has assembled for you a database of information from around the town, just collected from various different places around town, that they're going to give to you so that you can try and figure out what happened in this mystery. And you can download that database in your CS50 IDE by running this command. wget followed by that URL, and I'll go ahead and share a slide with it as well. So here's the command to download the database from 50ville, wget followed by this CDN URL, and I pasted it into the chat too, if you'd like to follow along. So what you're going to do in your CS50 IDE, if you're already in the SQL prompt for the shows database, again, you can press Control-C just to exit out of that database. And then you'll be presented with just this $sign prompt where you can start typing commands again. And here is where I can just paste in that wget URL, wget followed by the 50ville URL. That's going to download the 50ville database to your IDE. And let's just take a look at it, see what's inside. I can open up the database for call by saying SQLite3, then a space, then 50ville.db. So I've now opened up this database. And what's maybe the first thing I should do in this database now that I've opened it up? Yeah, Rachel and Lakshanta are saying .schema. So let me write dot schema. I want to understand the structure of the database. I want to know what are the tables, what are the columns. So let's take a look. And there's a lot of tables. I'll let you look through a lot of them to figure out what they are and what they mean and what the columns are. But there's one I want to draw your attention to first, which is just this first one. There's a table called crime scene reports. And the crime scene reports table has a year column, a month column, a day column, a street column for presumably what street the crime took place on, and then a description column, some text for a description of the crime. And so if I wanted to get a taste of what the crime scene reports table looked like, I could say select star from crime scene reports, and then let me just add a limit 3. Let me limit myself to just 3 rows rather than see all the crime scene reports. Let's just see a couple of them. And all right, it seems like I got some months, I got some days, and I got a couple of different streets on which crimes are taking place, and I have these descriptions of the crime. So a good place to start might be, I've told you when the crime took place, of the theft of the duck. It took place on July 28th. And I told you what street it took place on. It took place on Chamberlain Street. And so that should hopefully be enough to get you started with getting some information about what happened here. And then you might be able to do a little bit of digging from there. And so I'm actually going to stop talking for a bit, give you some time to work on solving this mystery for us. We don't expect you to completely solve the mystery in the next 15 or so minutes, but see if you can at least come up with a list of suspects, a list of potential suspects in the town, maybe a list no longer than 8 names. I want maximally 8 people who we think might be the theft in this case. So here as a review is what you're going to do. You can download the database using that wget URL if you haven't already. Your goal is to identify a list of suspects, a list of 8 suspects. If you can narrow it down further, narrow it down further. But all the information I'm going to give you so far is that the theft took place on July 28th and that it took place on Chamberlain Street. Beyond that, it's going to be up to you to figure out what you're going to look for, how you're going to try and access the information you need to access to try and solve this mystery. I'm going to give you about 15 minutes to assemble a list of suspects. If you need any help with anything, feel free to ask questions in the chat. You don't have to post your answers or your suspect lists in the chat. Just questions if you have any, if you're confused about how to keep making progress and how to move forward. And you're welcome to post questions on Ed as well. But in about 15 minutes, we'll talk about how it is that you could have made some progress here. So best of luck trying to solve this mystery. I will start a 15-minute timer, and we will see you in about 15 minutes. Good luck. All right, welcome back, everyone. How did we do? Did we get a suspect list? Or maybe progress towards a suspect list? Find out maybe some additional information that we might be able to use? There's some disagreement about who is or isn't on the suspect list. All right. Well, let's take a look at how you might have gone about starting to approach this. I'm not going to give away the answer to the mystery now. I'll give you a path towards the suspect list. Leave it up to you to make some progress if you'd like to. So here's what you might have done. What was the first query that someone ran? We know the structure of the database now. What's the first thing you could write if you were trying to make some progress here? All right, Lakshanta's selecting from the crime scene reports table, looking for something that took place on July 28th. I see a bunch of queries of that form. Let's try it. Select star from crime scene reports, where month equals 7 and day equals 28, and street equals Chamberlain Street. Let's see what we get. There's only one result. All right, and here's the description. Theft of the CS50 duck took place at 10:15 a.m. at the Chamberlain Street Courthouse. Interviews were conducted today with 3 witnesses who were present at the time. Each of their interview transcripts mentions the courthouse. All right, what now? Where to next? Interview transcripts. All right, a bunch of people are thinking, let's try and figure out interview transcripts. And one is saying we can look for people that mentioned the courthouse in their interview transcript. Now, how could we do that? How could we check for a transcript that mentions the courthouse? Yeah, we can use the like syntax that we did a little bit before when we were looking for television shows that were about the Titanic, for example. And so you might have noticed there was an interviews table. If I type .schema interviews, I can see the structure of that table. This table has year and month and day as before. We also have a transcript column. So let's go ahead and select star from interviews, where the month is 7 and the day is 28, because that was the day on which the interviews were conducted. And transcript is like % courthouse %. So again, we're looking now for all of the interviews on that day where the transcript somewhere in it mentions the courthouse, using that like keyword to do that. I run the query and we get 3 results. 1 interview from Ruth, 1 interview from Eugene, 1 interview from Raymond. And all right, 3 different interview transcripts. Let's just read one of them. Let's read Ruth's. Sometime within 10 minutes of the theft. All right, so I'm thinking to myself, within 10 minutes of the theft, anyone remember what time the theft happened? 10:15 a.m. Great. 10:15 is when the theft happened. So sometime within 10 minutes of that, so between 10:15 and 10:25, I saw the thief get into a car in the courthouse parking lot and drive away. If you have security footage from the courthouse parking lot, you might want to look for cars that left the parking lot in that time frame. Do we have any way of knowing who left the courthouse parking lot between 10:15 and 10:25? Great. Stephen talks about the courthouse security logs table, which you might have noticed if you ran .schema. I'll run .schema now on courthouse security logs. Let's see how this table is structured. We got month and day. We've also got hour and minute. And yeah, we also have this column called activity, and I'm not quite sure what the activity column means. Let me just, for good measure, select some data from courthouse security log. I don't want all of it, but let me limit myself to 100 rows. Let's get 100 rows of data and just look at that and see what it looks like. All right, here's what we're dealing with. We got a bunch of days and months. We have got some times and hours and minutes. We also have either exit for exiting the courthouse, entrance for entering the courthouse. And interestingly, we got some license plates too. We got a license plate number column that we might be able to use here. So let's give that a try. Let's put together a query. let me select star from courthouse security logs, where the month equals 7 and the day equals 28. And now I need to do the time. The hour was 10, and the minute should be greater than or equal to 15, and the minute should be less than or equal to 25, somewhere between 10:15 and 10:25. And I also know the activity should be exit. It needs to be people who are exiting the courthouse at that time. So I narrowed it down by date and by time and what the activity was, entering or exiting the courthouse. Let's try it. And okay, we've got 8 cars, it would seem, that left the courthouse between 10:15 and 10:25 on the day of the theft. We're making some progress. What do we do now? What do we do now with this information? We don't yet know which of these cars was necessarily the thief's car. We know the thief left sometime in that 10-minute range. Chloe is suggesting we search for people by their license plate. So we have a people table. Let's take a look. .schema people. For people, we're storing their name, their phone number, their passport number, and their license plate number. All right, so we have their license plate number stored. Let's try and query for that. Let's select the names of all of the people, where their license plate is in, and then this list of license plates. I'm going to select license plate from courthouse security logs and just copy those same conditions that I ran a moment ago. So nesting a query. But what this query is now doing, and it's longer than most of the queries we might have written before, but this innermost query is getting me all the license plates from the courthouse of cars that left during that 10-minute window when we know the thief left the building. And now that we have those license plates, we're looking for all of the names of all the people who have a license plate in that list. Let's go ahead and press return. And here's our list. Patrick and Amber and Elizabeth and Roger and Danielle and Russell and Evelyn and Ernest. List of 8 names of people who we think might be the thief. Now, from just this information, we don't have much of an ability to narrow it down any further, but we do have now a list of suspects. And I imagine that you could try to make some progress by running some more queries, by maybe looking at some other interview transcripts if you wanted to. So hopefully now you get a sense again for relational databases. This is a different database, different tables, different columns, but the structure is very similar. These connected tables with columns that are linked together between different tables. So as we wrap up today's session on SQL, we do have a little bit of optional homework for you. If you'd like to try your hand at a little bit more SQL yourself, you can find the homework in the slides that we've been going through today. The first piece of homework is based on movies. It uses the IMDb movie database, very similar to the television show database, but structured a little bit differently. So you'll have to study the new structure of this database and figure out how you're going to answer these questions. What are the movies that were released in 2008? What year was Emma Stone born in? How many movies have a rating of 10.0, a perfect 10.0 rating on IMDb? What are the titles and release years of all of the Harry Potter movies in chronological order? And you can assume that if the title of a movie has the words Harry Potter in it, that's a Harry Potter movie. We want to know who starred in Toy Story. And finally, we want to know what are the movies in which both Johnny Depp and Helena Bonham Carter starred. So a couple of questions for you to answer based on a movies database. It's very similar to the TV shows database. And your second homework assignment, if you'd like to, is to finish solving the 50ville mystery. Keep making some progress. We have a suspect list, but we can narrow it down further. Your task is to discover who the thief is, but also what city they escaped to and who helped them escape. Who is the thief's accomplice? Who helped them escape? You can find all of the materials from today on the slides. You can get to the slides at this URL. But before we wrap up, a couple of final things I should note, that there are some other seminars after today's seminar that you can attend if you want to, other of CS50's New Year's seminars. We have one that's going to be later this week, starting tomorrow, in fact, about Linux, led by Kareem on our team. And next week, we'll have some seminars on game development, led by Colton. So if those topics are things that are interesting to you, we hope to see you with those as well. And finally, we would love to get your feedback on today's session. We always like to ask for some feedback about what you thought about the session, things you liked, and how we can improve future sessions. And so if you could go ahead and fill out this URL that I just pasted into the chat, cs50.ly/feedback. Won't take very long, just a couple of brief questions for you based on today's session, but we would love to get some feedback on what you thought. After you fill out that feedback form at cs50.ly/feedback, that officially ends today's session. Thank you all so much for being here. And a special thank you to all of our volunteer mentors who have been in the chat and on Ed today, helping to answer your questions as well. So enjoy the rest of your day, and we hope to see you at a future seminar.